I mean, it's just a two-liner, isn't it? So with question number 2, I think number 2 is more sophisticated. So with number 2, what do you want me to do? What do you want me to do?
Use substitution?
And number 2?
Yeah.
Yeah, I think that's the answer. Forget about number 2. Don't you guys think I'm so way off on number 1? Think about it.
Yes.
Watch. To differentiate the product of two functions, I want a yes or no answer. Is this what I get?
No.
No, it's not. I think to differentiate the product of two functions is much more complex than that. I've got to use the product rule. And so since integration, or evaluating integrals, is the opposite direction of differentiation, maybe I shouldn't be walking so fast and saying, well, the integral of product is a product of two integrals. I don't think it's true at all. As a matter of fact, much of what you and I are going to do in the next chapter is just that, determining how the heck I deal with the product of two functions, the integrand position. We already deal with it to a certain extent because that's what I have. But the only technique I put in your back pocket is the technique of U subs. If you can't sit there in your chair and just scream out what an antiderivative is for the function integrand's position, that's the only tool we have available is a U sub. So I guess I made a horrible mistake, I gotta fix it. So to fix my mistake, help me with this. What can I allow U to be so that 2 things happen? Number 1, cleans up what you see in the integrand's position beautifully. And number 2, so that its derivative, whatever is over here, is, well, maybe neglecting a numerical coefficient, its derivative is in the integrand's position as a factor.
1 minus x squared.
I think it has to be. I think allowing U to be 1 minus x squared is the appropriate choice because it simplifies my denominator down to a nice clean root U. I can handle that. And besides that, when you look at x dx, I think committing to the substitution, when I relate du to dx, neglecting this coefficient -2 out front, I think that's exactly what I have circled. And so I do think that's an appropriate choice for my U sub. Let's run through it. I think that tells me that this particular integral ends up being nothing more than, can I pull the 3 out? But that just simply gives me the integral of the square root of U downstairs. What's next?
Yeah.
Oh,
Yeah,
so
finish
next
the
you
U sub.
want step.
No, same step.
Yeah, can we just say nothing next? I think what I have on the board is so horribly written. I would never write it. I can't just come in and partially replace something with u's, and now I got u's and x and the inside integrand's position. It has no meaning to me. Because when I look at the collection of symbols of this piece and this piece, it means commit to the process of anti-differentiating this particular expression with respect to that variable, and I can't, because that's a different variable than the x. So if you guys don't mind, I'll fix my horrible mistake. I think, yes, I'm sorry.
Can you take out like 3 and then say the x is d over -2?
I like that. So what you're saying is this. Another name for what's inside the circle is what's inside this circle right here. And if you isolate that in this equation, I think what's inside the circle is a -1/2 du. More appropriate. Would you guys agree? But you know what? I think that's going to leave me with a -3/2. Because I'm not trying to annoy you. I'm just trying to show you the common mistakes I see when it comes to notation. I think that leaves you with -3/2. Integral of U to the -1/2. And you know what? That is a piece of cake. Because I think what's in the integrand's position is nothing more than a power expression, and I can apply the power rule for anti-differentiation, which says the following. I'll up my exponent by 1. Divide by the new exponent, which is a fraction, so if you guys don't mind, I'll invert and multiply. And then deal with it. So what's next? Yes, sorry, it was something you brought up. I think what I've really done from here to here, when it comes to what's above my fingertips, I have anti-differentiated. Now, the process of anti-differentiating is a process of applying this function. I can really think of that as a function. And applying this function which means to anti-differentiate what's inside. Since I've already done it, I don't think I have a notation left over. Do you guys see my point? Now that I've come up with one antiderivative, can I just finish this up, you guys, by giving you all antiderivatives? Oh, by the way, number one, I can clean up. I can rewrite in terms of radical notation. Oh, and I can even yeah, back substitute. Is there? If you're happy with that, what about the next question? What seems appropriate? Secant or secant squared? Do you want me to get rid of the square? So get rid of secant squared. Well, why doesn't this work? Why doesn't this work? Well, not only is yours easier, I think I'm completely off for this reason. You know, to commit to this U sub, wouldn't be U have to be something like the tangent of do you guys see my point? I mean, I don't have a tangent factor in there. So I think allowing U to be secant or secant squared of anything doesn't do me any good. I overshot things because I don't have a tangent factor in there in the integrand's position. But what you guys are suggesting is this. Just quickly scanning things. You know, there is an understood factor of 1 over x in here. And 1 over x is a derivative of natural log of x. And since I got a factor of 1 over x in there already anyways, why not try letting u be the natural log of x? Again, because its derivative is a factor in the integrand's position. And so I think the integral of e to e squared of the secant squared of the natural log of x over x dx could be rewritten as the integral of secant squared of but 1 over x dx has the alternative name of
du.
And yes or no, can you and I anti-differentiate secant squared of u off the top of our heads just like that? Absolutely. Of course, my bounds change, don't they?
Yep.
Natural log of e is
1, 2.
Are you happy?
No C.
You know, I don't mind if you put plus c up here. It's just it'll cancel it out somehow. It's just not necessary.
So isn't tangent of 1 just pi over 4?
The inverse tangent of 1.
Oh.
Therefore. Is he happy?
Yeah.
Come on, everybody in harmony. Happy? No. I think everything on the board's wrong. I think it's horribly wrong. Because if I were to graph y equals a secant of x, isn't that the reciprocal y by its cosine? The cosine cross the x-axis at... I said the cosine cross the x-axis at... pi over 2. Is pi over 2 between 1 and 2? Well, pi is about 3, so pi over 2 is about 3 halves. Is that between 1 and 2?
No.
It means I got a vertical asymptote. It means I cannot apply the fundamental theorem of calculus, because that function is not continuous. And so I might even subclassify this as an improper integral, and we're going to have to learn how to handle that this semester. You want to know the real truth?
So if we answered it like that, did we get it wrong?
Oh, no, you guys, it's more serious than that. Check this out.
That's seriously. It's more serious than what it's super well.
Watch my solution. You see how I evaluated it wrong? I changed the 1, 2 because after I wrote the solution, I realized my function wasn't continuous, and I forgot to go back and change it on the quiz I just gave you. So that was really my mistake. Apparently, none of you caught that. So yeah, I don't mind. I'm very happy with this. But I just want you to realize I really did make a mistake. And when I finally typed up my solutions to make sure this quiz is okay, I realized, oh, it's not continuous over there, and I changed it on my solutions page. I just forgot to go back and change the original page. I'm sorry, that was my mistake. But anyway, if you gave me that for now, I'm happy. I just want you to understand, it really is wrong. Can I get rid of it? And I'll slap these on the homepage sometime.